Okay, so here we are, chapter 3, and this lesson specifically, transformations of graphs, is the first concept in chapter 3. So what we're going to be looking at here is how does f of kx and k times f of x transform the graph of f of x. So what we're looking at here is a vertical shift compared, or vertical stretch compared to a horizontal stretch or compression. Okay, and we'll begin with this problem. And again, this is just a little review here. Find the equation of the exponential function that passes through the points 2, 36, and 4, 81. So what we're looking at here, the form or general form of a exponential, y equals a times b to the x. So what we know here is we know an x and a y value for two coordinates. So if we substitute those numbers in for x and y, we would end up with 36 equaling a times b squared, and we would end up with 81 equaling a times b to the fourth. So what we want to do is go ahead and solve this system of equations. The system has two variables, and we have two equations, so we should be able to do that. I'm going to go ahead and isolate the a values because they don't have an exponent by dividing by b squared. So I have a equals 36 over b squared. And then over here, I'm going to divide by b to the fourth. So I end up with a equaling 81 over b to the fourth. Now, since I have a by itself in both of these, this is equal values method, I can let the two fractions equal one another. So 36 over b squared equals 81 over b to the fourth. Cross multiply. Because we have two fractions equal to each other, it's called a proportion. So 81b squared equals 36b to the fourth. Get all my b's on the same side. I'm going to move the smaller number of b's. So 81 is going to equal 36b squared. Okay, at this point, I would want to go ahead and divide by 36. I'm going to go over here for some more space. So I have 81 over 36. Equaling b squared. Okay, now that 81 over 36, you could divide that, get a fraction or a decimal or whatever, or we could just reduce this, okay, to 9/4 equaling b squared. Okay, and then to get rid of the square, we would want to square root both sides. So over here, I square root each. I square root to 9, I square root to 4. So b equals 3 over 2. I am not finished. Remember, the whole point of the problem was to find the equation. Okay, I found the b value. Okay, I still need to find the a value for this particular equation. So I got to take my b value, substitute it back into one of my originals, and solve for a. So let's do 36 equals a times 3/2 squared. And now I want to solve for a. So 36 is going to equal 9/4 a. Instead of dividing by a fraction, I should multiply by its reciprocal. So I'm going to multiply both sides by 4/9. 4/9. Okay. So I end up with the 4/9 cancels out over here. So I have a equals 36 divided by 9 is 4. 4 times 4 is 16. So still, I am not finished yet because, again, the original problem asks me to find the equation. I found A. I found B. You wouldn't believe how many people do that work, all of that work, make all the right steps, and never actually write the equation of the line, which is 16 times 3 over 2 to the x. Now, I did all that work by hand, but again, I'm strongly encouraging you to consider using the calculator, okay, the TI. Remember, you go to Stat, Edit, okay, you put your x values in L1, you put your y values in L2, Stat, Calculate, and this time expreg. Okay? And that would be your steps here to do this on the calculator. On a test, I would strongly urge you to do that. It is the most accurate way, and it saves you some time from doing all the work. Okay? A colony of bacteria begins with 3,000 members. 4 hours later, the population has decreased by 20%. What is the effective growth rate of the bacteria? How long until the population triples? Okay, what we're looking at here is an exponential. All right, so we're looking at y equals a times b to the x. A is the initial value. B is the multiplier, or the percent increase in this case. Okay, so, and we're going to write this equation in hours. All right, so first things first, we know the initial value of 3,000. That's given. So A equals 3,000. These are all of our givens. We know how fast it's increasing, 20%. Okay, so we know B is going to be 1 plus 0.20, which is 1.20. Again, that was a given value. X is going to be time. Okay, and it's increasing this 20% every 4 hours. So, you know, not 4 times an hour, it's every 4th hour. So it's actually going to end up being t over 4. Every 4th hour it increases. All right, and then y is our future value of whatever we want to find. All right, or it's the number of bacteria. So if I write the equation with everything I know, I didn't have to do much work here. They gave me what I need. I have y equals 3,000, 1.20, 20% increase, to the t over 4 power. Okay? Now, the second part of this question here, though, is how long does it take the population to triple? So if I triple 3,000, I'm at 9,000. So I substitute 9,000 for y. Okay? And I solve. So first steps first, a lot of people want to multiply these two together. You cannot do that because the 1.20 has an exponent. All right? So we divide by 3,000. A lot of people want to subtract 3,000 as well, but 3,000 is not being added. So we end up with 3 equaling 1.20 to the t over 4 power. Now this is where it gets a little sticky because we haven't learned about, well, you have in Algebra 2 learned about logarithms, but in this particular course we haven't. Okay, but if I'm solving for t here, I could use guess and check if I really wanted to. I could graph 1.20 to the t over 4 power and then graph 3 and find their intersection point on my calculator. Or I could use a logarithm to find this, and I would know in that case that t over 4 equals the log of 3 divided by the log of 1.2. If you don't remember that from Algebra 2, then that's, you know, here's your mini lesson on that. So then what I want to do here is, let's see, log of 3 divided by the log of 1.2 equals 6.0256. So t over 4 equals 6.0256. And then I times both sides by 4. So I end up with a time of 24 hours. So about 1 day. Okay, so some new stuff here, right there. That's not new, but new for this course. And that's the easiest way to go about it. Okay, next. The half-life. Oh, half-life. That's a topic we've been talking about of uranium-235 is 4.49 times 10 to the 8th years. That's a lot of years. If a disposed fuel rod containing 5 kilograms of uranium-235 today, how much of this radioactivity will it continue, or will it contain 1 million years from now? Okay, Dr. Evil. So, first things first is to write the equation for this uranium. Okay, and what we're going to look at here is the initial value. All right, we know some givens. We know the initial value. All right, so y equals a b to the x. Okay, so givens. So we have some given values. All right, we know that our initial value, our starting value is 5 kilograms. We know what our multiplier is. It is 1/2 because we're talking about half-life. Okay. Our time here, it happens once every 4.49 times 10 to the 8th years. Okay, not that many times each year. Okay. So what we're going to do here is we're taking our time. It's going to be t divided by 4.49 times 10 to the 8th. Okay? So if I go ahead and write my equation then, I end up with y equaling, okay, 5 times 1/2 to the t over 4.49 times 10 to the 8th. I want to know how much of this isotope will it contain 1 million years from now. So 1 million years is a time. So time equals 1 million. Okay. You can also write that in scientific notation. 1 times 10 to the 1, 2, 3, 4, 5, 6. Okay. So here we go. We would substitute that in for t. So 5 times 1/2, 1 times 10 to the 6th, divided by 4.49 times 10 to the 8th. Well, because this, basically what we're looking at here is we haven't even had one half-life happen yet. So, you know, it's not going to be 2.5. It should be a number bigger than 2.5 because 1 times 10 to the 6th is smaller than 4.49 times 10 to the 8th. Okay, so if I use my calculator for this, obviously I don't want to do that by hand. 5 times 1/2 to the power of 1 times 10 to the 6th divided by 4.49 times 10 to the 8th. Enter. So 4.99 kilograms of uranium will still be remaining. So y equals 4.99 kilograms. So we only lost 1/10 of a kilogram in 1 million years. Okay, so you can see that the reason why, you know, radioactive material is being released is not a very good thing. It takes a very long time for that to be disposed of. So next question then. Nearing the end, how does the f times kx, or f of kx equal k times f of x transform the graph of f of x is the essential question. So we have h of x pictured there. We want to graph -3 times h of x. So if we're doing that, we're taking -3 times every y value. Okay, so here this y value is 1. 1 times -3 is -3. This y value is 1. 1 times -3 is -3. This y value is -1. -1 times -3 is +3. Okay, so you can see I'm starting to form this graph. Here the y value is 2. 2 times -3 is -6. Okay, and then let's use this y value right here as 1. 1 times -3 is -3. Okay, so now that I have all my points, I can go ahead and connect those dots to get my new graph. Okay, and go ahead and put arrows at the end of those. All right, and that's what that would look like. Okay, so I stretched it by 3 and I flipped it. All right, now for the second part here, I have 2 times x inside here. But remember, it's inside parentheses, okay, which means 2 things. It means horizontal, all right, and it means opposite. So actually, I'm going to take each of my x values, okay, and take them times 1/2. All right, so right here, my x value is 2. 2 times 1/2 is 1. Here my x value is 3. 3 times 1/2 is 1.5. Notice the y values aren't changing. Here the x value is 0. 0 times 1/2 is 0. Here the x value is negative 1. Negative 1 times a half is negative a half. Okay? Here the x value is negative 2. Negative 2 times a half is negative 1. Here the x value is 1, 2, 3, 4, 5. 5 times a half is negative 2.5. Okay? So now that I have all of those points, I can go ahead and draw that line, or that portion of the line, all right, with the horizontal shift. Okay, and this horizontal transformation is actually a compression, and it should look like one once I'm finished. So put my arrows on, and you can see I've basically taken my graph here and I've squashed it down this way. Okay, I've compressed it horizontally from both sides. This side and that side. Okay. And last and not least here, how do we, again with transformations, we want to rewrite this equation in y equals a times b to the x form. I know this is one part that some of you are struggling with, so hopefully this helps. And again, what we're doing here is we're basically doing our laws of exponents or properties of exponents backwards. So here I see subtraction. If I see subtraction, I'm thinking division. So 3 times 4 to the 2x over 4 to the first. Okay, so I took this exponent and I now separated it. All right, now what does that do for me? Well, if I have 3 and the 4, I can write that as 3/4 times 4 to the 2x. Okay, so now I took 1, 2, 3 shifts, and I have 1, 2 shifts. Okay, secondly, all right, with that 4 to the 2x, I can look at that as 4 squared to the x power. Because again, when I have power of powers, I multiply. So if I have multiplication, I can separate that into power of powers. Why does that help? Well, hopefully everybody here knows what 4 squared is. 4 squared is 16. So I end up with 3/4 times 16 to the x. And that's all the farther I can go. All right. So same thing over here. All right, same idea. I see subtract. I guess I should have thrown an addition one in here. Let's go ahead and make that addition. Okay. That'll probably screw some stuff up, but oh well. Okay, so what we have here is 4 times 9 to the 1/2 x times 9 squared. Okay. Now the reason I was able to do that is because I have addition. Addition means multiplication, so I can separate that, okay, using multiplication. Why does that help? Because I know what 9 squared is. 9 squared is 81. So 4 times 9 to the 1/2 x times 81. Now the reason that helps is because multiplication is commutative. I can do it in any order I want, or group it however I'd like, associative. So 81 times 4, okay, gives me 324 times 9 to the 1/2 x. Again, I have multiplication here, which means I can separate that into power of powers. So 324 times 9 to the 1/2 to the x power. The reason that helps is because I should know what 9 to the 1/2 power is. A 1/2 power is the same as a square root, so I end up with 324 times 3 to the x. Okay? And I believe that is all.